So today we proceed with the lesson 4 of our course, Sec 208, Advanced Instructions in Computer Science Education. And the topic is on curriculum development in CSE. Let's see how this will go. So what do you mean by curriculum development? What are the key components, or what are the key considerations, and the strategies to implement and stuff related to that? That is what we're going to do. I wrote here what you should expect in the next maybe 40 minutes maximum, hopefully. So you should expect the fact that we deal with key considerations when designing curriculum for computer science education. Then we look at the curriculum component. What are the kind of topics that or themes that could form the curriculum of CF for secondary school student, of course, computer science for secondary school. I think they also call it computer and ICT or something like that. Then there will also be strategies for implementation. This is just one slide, and then we will round up the class. So you should know that to design a curriculum is not a joke, and people actually make their career and spend all their career, 30 years or 35 years of service, developing, designing, implementing, evaluating curriculum. So, and this is an opportunity for you as well. When you graduate from this program, you can also get a job with National Educational Research Development Council, NERDC, where you can work on planning curriculum for Nigerians, or developing curriculum for Nigerians, or evaluating curriculum for Nigerians and stuff like that. So you can get a job there, not necessarily becoming a teacher, All right, so let's start with the very first point, which is on key considerations in curriculum development. What are the things you should consider when you are developing a curriculum? All right, so this is what we mean by key considerations. All right, so there are three things that you should consider, or let me say there are three topics under which there are a lot of things. So we can discuss key considerations under three subheadings. The first one being aligning curricula with standards and learning outcomes. All right, this is the very first consideration you should take note of: the alignment between the curricula and the standards, okay? The curricular standards and the learning outcomes, what you really want your student to achieve. Then there should also be sequencing and scaffolding of the content. All right, you want to sequence it, you want to move from simpler, to more complex, from your specific to general and stuff like that. So, and then the last thing you should consider, okay, is what we call addressing inclusivity and the diversity. Your curriculum should be open enough to accommodate everybody, to accommodate every type of student, to accommodate students of different learning styles and needs. So your curriculum should not just be the one that will favor only one type of student or one set of students without taking care of every other person. You are making this a national project. You are developing this curriculum for the whole country. So on every type of learner is in your class, every type of learner, this curriculum is going to bind on him or her. So for that reason, you need to make sure that your curriculum is inclusive and it accommodates everybody. All right, so let's start with aligning curricular standard with learning outcomes. Let's see that. So of course, you should remember that the curricular standards and learning outcomes, they are essential for creating a cohesive and structured learning experience for your students. So standards, when we say standards, what do we mean? They serve as a kind of framework for educational institutions, outlining the knowledge, the skills, and the competencies that students should acquire in the process of implementing the curriculum. So they help a lot. The standards actually help a lot in ensuring consistency in the quality of the program, which is computer science education. And when we say learning outcomes, these are things that are not new to you. And I think right from your day one, for those of you who went through NCE, you must have heard of learning outcomes several times, or they call it learning objectives, or, and then when you also get into the university, for those who came in through JAM, you might have taken some courses, Sec 103 and all other courses, in which most of these courses, you're going to have the learning outcomes spelled out for you so that you know what you are going to achieve by the end of the lesson. All right. So what about the process? There are some processes which you need to take when you are making these alignments. All right. The very first thing is you should identify the standard. What kind of standard do you want to have in your curriculum in which you are going to make a match between the standard and the learning outcomes? What is the frame of reference for this standard? The national, the state, or district level standards. You need to check this. Then what about the analysis of the learning outcomes? Since you have identified your standard, now you need to analyze the learning outcomes to make sure that there is a match between the standards and the learning outcomes. Okay? After that, then you evaluate the existing curriculum and see whether this alignment has taken place or not. Then you revise. If the alignment has not taken place, then you revise and develop a new curriculum. You either revise the existing curriculum or you develop a new one. Usually we used to revise. We don't develop new ones most often. We build on previous curriculum. I think since early 90s or so, we have the first curriculum, and then it was modified up to 2013, where the current curriculum, that is more than 10 years. It is also due for revision, but we don't know what any RODC is doing on that. All right. So we have 4 different stages in this process. You identify your standard, you analyze your learning outcomes, you evaluate the existing curriculum, and then you revise and develop accordingly. So we shall now take this one after the other. So identifying relevant standards. What do we mean? Where can you get the relevant standards? You need to look into the NRDC document, the curriculum for senior secondary school curriculum, or the one for basic education curriculum that covers primary 1 to GSS 3. For the senior secondary school curriculum, it covers SS1 to SS3. All right? So you can look at the Computer Science Teacher Association also, and then you can look at the K-12, which they have in some Western countries. Then, in the process of identifying relevant standards, you need to ensure alignment. Ensure curricula align with the broader educational goals and expectations. For Nigeria, we have educational goals. We have targets. We have a foresight and look at, okay, what will be the generation of our children? What do we expect them to know? What do you want to expose them into? So right now, there is a serious debate on the use of artificial intelligence, whether we should start from primary school. So the curriculum for computer science is now in a serious dilemma. And there is need for any RDC to come up with these things so that people can make their point and then revise the curriculum accordingly. In the last revision of the curriculum, I'm not sure if there was anything like artificial intelligence for junior secondary school or for even primary school. But we need to do that now because the world is changing, and the next 30 years to come, we don't know what might happen, in which there is no doubt that artificial intelligence and even more to come will be the champion or at the frontiers of education at the time. So you need to ensure alignment, and then you need to use a framework. Of course, there must be a standard. Whether you're adapting from another country or you are revising your existing one, at least there must be this cohesive and structured learning experience which you target to create for your students. And what we ensure that is making sure that you use the standard as a framework. All right? So after identify, you need to analyze the learning outcomes. Remember, we have 4 things in there. So you define specific knowledge. See, the learning outcomes has to do with the specification of knowledge, skills, and competencies that you want your student to acquire or you want them to gain. Then after you've identified that, you need to design instructional activities which must be in line with these learning outcomes. Then you need to make sure that the learning outcome is clear enough. It is open, it is clear enough. There is no ambiguity, all right? And it must carry along the assessment tags and then the teaching learning activities. So these are very important things when you are in the process of developing your curriculum. Then you evaluate the existing one. Of course, you need to check, evaluate textbooks, resources, and materials for alignment with standards and learning outcomes. You see, for every publisher, they will tell you that we follow the national curriculum. We follow the national curriculum. Do they actually say the truth? So for you to know whether they say the truth or not, you take the national curriculum by the side, and you take the textbook, and then you make a match. You make a match. We have so many publishers, including professional associations, like Mathematical Association of Nigeria. They publish textbooks for mathematics. And we also have the Science Teacher Association of Nigeria, STAN. They publish a lot of textbooks. Then we have some independent publishers, okay? So which publish textbooks? So you need to, and all of them, they used to claim that their textbooks are developed based on the national curriculum. You need to assess this when you are evaluating existing curriculum, so that you identify the gap. Okay, all of you have covered this area, but you have not covered this place. Okay, all of you have covered this place, but you don't cover it enough. So you identify the gap. Then after that, you ensure comprehensive coverage. Okay, the coverage between the content and the national standards and the content in the textbooks. As soon as you've done that, then you need to revise and develop the new curriculum. Okay, you identify the standard, you formulate your learning outcomes, you evaluate a system one. Now you revise your curriculum, and then you make. So these are the stages in which you might be evaluated on this. Like, for instance, you can be asked to write a concept notes on the process of developing a new curriculum. So you need to make sure these steps, they come in there. You identify the standard, you develop the learning outcomes, and then you do what? You evaluate a system one, and then you revise and then develop your new curriculum. So you need to now define the lessons. You can break down the content into lessons, activities, assessment, and then you modify your system ones. You make sure this is aligned with your standards, and then you provide structured learning for students, okay? And then in the process of providing structured learning for students, you need to make sure that there is coherence between what you are set out to achieve, the content in the curriculum, and what is actually implemented, which we shall get there. And that's why we move to the strategies. So what are now the strategies you can use? Okay, you have known the process through which you can revise existing curriculum, or through which you can develop a new curriculum. So what are now the strategies that you can use to ensure you have this? Okay, the very first strategy we talk about is what we call the backward design approach. Okay, this is just a bullet, which I explain each of these in details. Then after you take the backward design approach, you also have the Bloom's taxonomy. All right, I'm sure for some of you who took 203 or something, you might have heard of Bloom's taxonomy, or you took a course in education like Edu, whatever, I think 203 psychology. They will talk about Bloom's taxonomy in there. I expect them actually. Then after the Bloom's taxonomy, we also have the concept mapping. This is another strategy you can use to ensure alignment. Then the fourth strategy, which we shall discuss, is the cross-curricular connections. Okay, what are the cross-curricular connections that you can make? So let us take these one after the other. All right, after this session, I'm going to have a break. Then we discuss some things before we proceed. Okay, then backward design approach. What does this mean? What is backward design approach? Basically, you start with your learning outcomes. In backward design approach, you start with your learning outcomes. Okay, we want our student to achieve this in programming language. We want our student to achieve this in web development. We want our student to achieve this in website design. We want our student to achieve this in database management. You know, we want our student to achieve this in cyber security. We want our student to achieve this in artificial intelligence. You start with the learning outcomes. After you started with the learning outcome, the next thing will now be to look for content that will match the learning outcome. Look for assessment tasks that will match the learning outcomes. This is what they call backward design approach. Okay? After you've already got your learning outcome, you create a clear pathway so that the curriculum is designed intentionally to meet desired standards and learning outcomes. Are you okay with this? Then now focus on student achievement. You prioritize student achievement by making sure that you align the instruction. You align the instruction with internal learning outcomes. What the teacher actually teaches in class is in line with what is set out, and is in line with the internal learning outcomes. So this is what we call backward design approach. You start with the learning outcomes. They now look for content that fit into the learning outcomes. Okay. After that, you ensure that you prioritize student achievement. Okay. That's by making sure that your assessment tasks are actually in line with the learning outcomes and the teaching learning activities. This is what we call backward. This is a strategy through which you can make sure you develop aligned curriculum. Then you can also take into Bloom's taxonomy. So, you know, Bloom's taxonomy actually categorizes learning objectives or learning outcomes into 6 levels: the knowledge, comprehension, application, analysis, synthesis, and evaluation. This is on cognitive aspect, the cognitive domain. We also have affective domain and we have psychomotor domain. All right. So basically, we talk about cognitive domain now. I will show you a diagram where it incorporates all of these things. So through the Bloom's taxonomy, you can promote critical thinking, encourages higher order thinking skills and deeper understanding of computer science concepts. This is very important. And then you can make a balance. Okay, you want knowledge to be maybe 10%, comprehension to be 20%, application to be 30, analysis 30, synthesis 30, and so on. And then you can make a match and then have, at the end of the day, you can slash everything back to 100%. Okay, you make a balance between different levels of this student learning. So now look at this diagram. I think this will take a while. Let us study this diagram. So what you see here in this diagram is just a combination of the knowledge domain and then with the different levels of this knowledge domain. Okay, look at the cognitive aspect or the cognitive domain that has to do with the brain, the performance and everything. This is where Bloom's taxonomy comes in, where Bloom's actually define knowledge, comprehension, application, analysis, synthesis, and evaluation under the knowledge domain. And for you as teachers, what are the kind of verbs that you can use to bring out these domains, the levels of this domain, level of cognitive processing for this domain? There are some suggestions here for you. Under knowledge, you can see define, you can see describe, you can see identify, you can see list. These are the verbs that you can use. Under comprehension, you can see explain, you can see interpret, you can see give examples, okay? Under application, you have apply, employ, generalize, operate. And under analysis, you have analyze, break down, infer, compare, detect. Under synthesis, you have integrate, review, categorize, compile. Under evaluation, which is the highest level of cognitive processing, okay? You have criticize, evaluate, assess, critique, judge, validate, justify, examine. These are the things that we talk about when we say the level of cognitive processing under the cognitive domain. We can also move to affective domain, in which we also have some level of processing there, which are receiving, responding, valuing, organizing, and then internalizing. Okay, internalizing is the highest level. Receiving is the lowest level of affective domain, such as same as knowledge is the lowest level of cognitive domain, and then evaluation is highest level of cognitive domain. Under receiving, there are some suggestions of verbs, okay, which are accept, attend, recognize, and so on. Under responding, you have applaud, participate, compile, play. Valuing, you have it internalization, you have internalize, avoid, display. These are the verbs that you can use to qualify affective domain. The last domain of knowledge is the psychomotor domain, and it has again some levels. The lowest level is imitation, followed by manipulation, followed by precision, followed by articulation, and the highest level is naturalization, where you now take the knowledge now comes to you naturally. Just like you speak your language, it comes naturally from your mouth. You don't, you don't think it twice. You just open your mouth and all right. I know there are some suggestion of verbs in there, like align, place, repeat, balance, perform for manipulation, perform again for precision. All right. Then you have coordinate, act, for articulation. Then you have again do, carry out, and so on for naturalization. So you can see in there that some verbs that you will have in cognitive domain, they also appear in affective domain and appear in psychomotor domain. So there is a kind of match. You see, the intersection is not empty between this domain and the verbs that you can use to describe these domains. But this is very important for you as a takeaway from this lesson. And the reference through which you can read more about this particular, they call it PI, verb pile or something. The reference is there. When you get the slide, you can follow it and read more about it. So Bloom's taxonomy is all about the level of cognitive processing, the level of affective processing, and the level of psychomotor processing. So by designing your curriculum, this will help in actually spelling out your learning, internal learning outcomes. In fact, we need these verbs whenever you are stating the internal learning outcomes. Take note. All right. After taking that, to talk about the concept mapping. This is another strategy you can use, the concept mapping, where you can have a kind of, you can create visual organizers to illustrate connections between different learning objectives and topics. Okay, you can create some diagrams through which you can say, okay, this topic will be in line with this one, and this is a connection. At least we should have, let's say, history of programming before we talk about Java, or we should have introduction to basic programming before we talk about Java or C++. So this kind of thing, you look at it and then you align them. So you create that visual. Then you can facilitate meaningful learning through this, because this will help your students to understand the overall structure and coherence of the curriculum. Through that, we can also promote a deeper understanding of the concept, because now they can see how the things connect to each other, how they match, and then they can use that to develop what we call conceptual understanding. Okay, you must not design your topics in a kind of disjointed way. There should be connection between them, and the concept mapping will help you. In fact, some textbooks, they started doing this before any team. They bring about the concept mapping and even advise teachers on how, where to start and how to teach and how to connect this thing together. Some textbooks are doing this now. Okay, the last strategy is to make a kind of cross-curricular connections. Here we are talking about interdisciplinary or multidisciplinary issue, where, you know, computer science, for instance, it's cut across almost every field. So there must be intersection. You must bring this out. So this interdisciplinary learning integrates computer science with other subjects to enhance interdisciplinary approach to education. Through that, you can link it to meaningful contexts that foster deeper understanding and engagement, and you can also promote collaboration, okay, among your students. Yeah, I think this is a good place for us to stop. So far, what we have done, we've started with the consideration for this lesson, where we talk about the alignment, and then we talk about the curriculum we'd like you to have a kind of interaction between yourself and then look at what we have done. Perhaps we can make it okay, of what you have done, the process of aligning the curriculum, all right, the curriculum alignment with the standards. We discussed this. So in the process of doing this, what are the likely challenges you think as a curriculum developer, what are the likely challenges you think you could face while doing this? So I'm going to move this up, stop sharing. Okay. Stop sharing, and then give you the opportunity to talk about this. Yeah. All right. So the floor is open for you to make, you can unmute yourself. Now, Max, you have to allow your students, your colleagues to talk now. So you can unmute yourself and then reflect on this question. What are the likely challenges as a curriculum developer? What are likely challenges you think we can face when we are to implement all these nice things we talk about on the curriculum? Yeah. The likely challenges we can face. Let me know. Yep. Unmute yourself and speak. What are the likely challenges? Yes. What are the likely challenges we can face in the process, for instance, in the process of ensuring there's alignment between curricular standards and learning outcomes. Or in the process of evaluating existing curriculum, or in the process of identifying the internal learning outcomes. Okay, there is a comment in the chat that says the ambiguity of a particular subject or topic can make it a bit difficult to clearly state the goal or the learning outcomes of that particular topic. Interesting. Yes, you can also put it in the chat if your network does not allow you to speak, but it's better that you speak. So let's interact on this before we proceed. Okay. Okay, let me start calling your names now. Benjamin, Blessing. Blessing, Benjamin. So somebody mentioned in here that resource constraint. Blessing should be thinking before I finish reading this one. So somebody mentioned here resource constraints, that dealing with limitation in resources such as time, faculty expertise, and materials, which can impact. The question is about the challenges you think we can face when you are dealing with all this I'm talking about. Blessing, can we hear you? Yes, go ahead.
Okay. Please, sir, can you come again?
What are the challenges you think you can face when you are making sure there is alignment between curriculum standards and learning outcomes?
Okay.
As you are still thinking, let me quickly read this message from one of your colleagues. Okay. So the person said lack of educational materials in some schools. Maybe when you are trying to make sure the resources to be available, because if you want to teach a subject, you need textbooks and other teaching aids to help you. If you know what to teach and resources are not available, you know how to deal with it. Unfortunately, that is going to be a problem. That is a challenge. Thank you. But that also going in line with the second comment about resource constraints. That if there are limitations in resources and either in the physical resources or in the number of teachers or in the time or in the teaching materials, that could be a problem. So there's another comment, Blessing, we are still coming to you, be thinking well. Another person here says, ensuring the curriculum meets the local, state, and national education that can be complex, and it requires a continuous update, especially in this country where we have a lot of people with different dialects, with different languages, different tribes. How can you now ensure that this curriculum standard goes around everybody? There is a call now that we should be teaching, at least in primary and secondary school, we should be teaching in local languages. But when you take Kaduna State, for instance, which language are you going to pick for teaching in Kaduna State? If you say you are taking Hausa language, that is a serious problem for you, because there are a large number of population in Kaduna State that don't speak Hausa in any way. I'm sure more than 2 million people in this state don't speak Hausa language. So how will you now push away those children and you want to use Hausa language? Even within Hausa as a language, there are also some dialects that are difficult to understand by others. So this is a big challenge, especially in the multi-national, in the multi-ethnic, in the multi-tribal, in the multi-language like Nigeria. So this is a complex and serious problem. Yeah. Now, Blessing, can we have you? Yeah, Blessing, we are waiting for you. I'm calling another person while we are still waiting for Blessing. You can type it if your network doesn't allow you to speak. That is, I will read it out. That one is fine. Okay, let's take we again. You should be praying. I don't take you. Yes. Let us take Isiaku Muhammad Kudu. Isiaku Muhammad Kudu. For you, what are the challenges you think we can face? You need to unmute yourself, Isiaku, if you are speaking. Yeah? Isiaku Muhammad Kudu. If you are called and you have nothing to say, I'm taking notes. Isiaku Muhammad Kudu. We didn't get him. Okay, let me see. There are some messages in the chat now. Let us have it while we are waiting for Kudu. Okay, developing effective assessment that accurately measures student learning is a challenge, could be a challenge. That is true, especially when you are saying student learning. Are you talking about cognitive alone, or you are talking about affective, or you are talking about psychomotor? So usually most of our tests, they are based only on cognitive. We don't look at this affective aspect, we don't look at this psychomotor, and they're very important. So developing, I agree with you, developing effective assessment that accurately measures student learning could be a challenge. Okay, another one from Abdulaziz Ibrahim, insufficient involvement of teachers, students, and communities in the curriculum updates could be a problem. Yeah, I think we mentioned this under resources, which is true. Okay, somebody's asking of the question again. The question is about the challenges you can face when you are developing a curriculum. So Isaac just left. He doesn't know that I'm taking notes. Okay, there's another one from Zainab that says that curriculum overload, too many topics to cover, leading to superficial treatment of important concepts. This is correct. I agree with you. And in fact, a serious challenge in the not only at secondary school, even at university level, is the fact that you have curriculum overload. There are so many topics to treat. Okay, and you end up skipping some important things, and then perhaps you will not be able to use effective teaching strategy because you think it will waste your time. So this is a big challenge we are facing in the curriculum development. We need to find a way to break down this bulky curriculum, and then maybe diffuse and remove the unnecessary one, and then move on with the little one that we know will be beneficial to our people. All right. The next comment here is the lack of understanding and familiarity with cross-cultural approaches, cross-curricular approaches among students and teachers. Yeah, I think that this is true. You should be able to know that now we are talking about interdisciplinary or multidisciplinary, where especially for computer science as a field, there is no single field in which computer science will not flourish. In the health sector, in security sector, in the education sector, in the industry, in the finance, in economics. So there is a need for us to let these students see these things right from the onset, right from the secondary school. All right. The next comment here says, okay, this is a question for me. Does the cognitive ability of the student in a school affect the development and implementation of the curriculum for that particular school? Is the other way around. Is the curriculum that will influence the cognitive ability of the student? If your curriculum is well planned, you see, there's one thing I believe in, and that is what we call growth mindset. I don't believe nobody can not achieve anything. You can achieve anything in your life. This is what I believe. Okay, and this is what I do when I teach or when I interact with people. I don't look down on people that this one they have low cognitive ability, they cannot do better. Everybody has the potential to do better. You just need to organize a curriculum in a way that will give them the opportunity to flourish. So I will say it is the other way around. It is the curriculum implementation and development that will affect the cognitive ability, not cognitive affecting the development and implementation of the curriculum. Okay, thank you. Incorporating diverse learning style could be a challenge. How? He said that, he said that designing a curriculum that accommodates various learning styles and needs of students, including those with special educational needs, could be a challenge. Yeah, that is true. That is true. We have people that cannot see, they only hear, and we have people that cannot hear, they only see. We have people that are both deaf and dumb. How will you teach them? Okay, so how are we going to have a curriculum that will take care of these people? Unfortunately, it is bad, especially in secondary school or in primary, even at the university level. So we usually neglect people with special needs, okay, and concentrate only those that are more able than others. Okay, I think there's the last one. We are fine. We can go on. Somebody put in here cultural difference and unavailability of proper materials for teaching. Yeah, this is also true, and it falls under resources. So I think now we can proceed to our next talk, which is still on the curriculum, still on the alignment, however, with more taste on some strategies, I guess. Yeah, sequencing and scaffolding of computer science topics. I want to believe you have my slide in front of you now. So the next aspect of this lesson is on sequencing and scaffolding of computer science topics. Okay. By the way, when we say sequencing, we are referring to the deliberate arrangement of topics and skills in the curriculum to facilitate effective learning. So it involves determining the order in which concepts will be introduced to students, considering their complexity and prerequisites. This is very important. Okay, you don't just start, bam, with introduction to Fortran. You start with some little things. What are computers? History of computers, identification of different parts of computer. You know, they should get used to this first before you bring in programming. So there must be sequence. And then the sequence must follow in a related manner. Okay? So the goal of sequencing, the essence of doing this sequencing is one, to build on prior knowledge. So that you can use your prior knowledge, okay? You can see everybody, this is the mouse, everybody, this is the keyboard, this is this, this is that. They know it. By the time you're not teaching them how to use it, they can now recall, okay, it's like this now, we've seen it before. So they can build on their prior knowledge. You can start with basic, programming in basic, before you move on to Java. Because you can see some intersection. You know, basic is very simple. Just some few commands, and you are done. Unlike in Java, whether you have to talk about loops, so many other things, which are more complex than that of basic. So you need to introduce the simpler to them so that they can build on the simple knowledge to acquire the more complex one. So the essence of sequencing, or the goal of sequencing, is to achieve this, to build on prior knowledge. Number two is to promote conceptual understanding. And conceptual understanding, which is different from procedural understanding. Okay? And again, it's different from factual understanding, like Biggs, we say, one of the top guys in teaching higher education. Okay? So when we say conceptual understanding, we are talking about the linkage between different concepts in your brain for you to see, okay, I can see how quadratic formula is related to programming in Java, for instance, because you need the formula from quadratic equation to program, to write a program on solving simple quadratic equations. So you can see the link. Why BODMAS or BEDMAS or PEMDAS is important when you are dealing with algebraic manipulation. Okay? So why logic is important when you are dealing with loops in Java. So you can see, so this ability to find or to identify links between the topics you have taught is what we call conceptual understanding, which is actually different from procedural, where you are just given a formula and you are just to mechanically apply the formula. Okay, step one, look for the coefficient. Step two, do this. Step three, do this. These are procedures, and they call that type of knowledge procedural understanding, in which if you forget the formula, you will not be able to solve the problem. You want to calculate force, which is mass times acceleration. If you don't remember that force equals to mass times acceleration, you are in trouble. You must get the formula. So the knowledge of your ability to apply that formula is what we call the procedural understanding, to apply the formula. All right, and to recall it and apply it. There are all others, several examples we can talk about here where you apply procedural knowledge. But here we are talking about the conceptual, and there is this debate. Okay, there is this debate that conceptual understanding or conceptual knowledge, is it better than procedural knowledge? Question one. Question two is that, is there any intersection between conceptual knowledge and procedural knowledge? That is, do you need procedural knowledge to develop conceptual knowledge, or the other way around? Do you need conceptual knowledge to develop procedural knowledge? Researchers, scholars, they have debated this often. But what I think is closer to the truth is that both conceptual knowledge and procedural knowledge, they are interwoven. They are what? Interwoven. You need the knowledge of conceptual to deal with procedural calculations, and you need the knowledge of procedural to deal with conceptual calculation. So this is but you can also explore this kind of debates on your own. All right. So another goal or another benefit or another aim of sequencing our curriculum is to ensure there is logical progression. Okay, in such a way that we structure the curriculum from gradually increasing the complexity from the simple to the complex, from linear to complex, to non-linear. So you increase it from lower level to higher level. So this is these are the things that we need when we are talking about sequencing. So sequencing is going to do three main things for us, or we are going to achieve three main things if you go through sequencing. Number one, we'll be able to build on prior knowledge of students. Number two, we'll be able to promote conceptual understanding. Number three, we'll be able to ensure logical progression. Okay, we shall take this one after the other. How we can see. So there will be less talk. All right. So on building on prior knowledge, how can you do this? You can build upon student prior understanding to connect new concepts. You can enhance their understanding through this, and then you can support their cognitive development. When you are able to see a connection between what you know before and what you are being taught now, that is the beginning of gaining in knowledge. You should be able to see what you know before, how it connects to the present learning. This will make it stick in your memory and will make it difficult for you not to talk about it even when this particular course has ended. Okay, when a particular course is ended, you'll be able to say, this thing is linked together with this now. Yes, we can see how it is. And then you move on. Like what some of the things we are taking now, when you get to 300 level, you will see some connections. I'm not sure if by now you are seeing some connections between what you are dealing with in another course in education or in another course in 100 level. So this kind of curriculum that we preach, okay, where we're going to have a kind of interconnection between them. We shall talk about Spira very soon. So building on prior knowledge will support cognitive development of the students. And how can you promote conceptual understanding? Don't mind the equations on the board where that lady is writing, Leave that one for those in partial differential equation. By the way, that is partial differential equation for some of you who have little knowledge of mathematics. All right. So in promoting conceptual understanding, there is going to be this logical order for you to do that. Introduce concept in a logical order to enhance the understanding. Then you can encourage critical thinking and even analytical thinking, because you can always remember, this one is linked to this now. We have done this in education in Edu 204, for instance. We can see is Bloom taxonomy again here. The psychology of learning, we have learned about something on theory. Now we are talking about theory here again. Okay, so critical thinking will come in, and then you'll be able to challenge the reality. Then you can help the student to see a clear connections between related topics when you promote conceptual understanding. All right. Then in ensuring logical progression, there should be gradual increase in complexity. I've just mentioned this before. The foundation, this is from foundation to advanced, from beginning to highest, from simple to complex. You need to do this while you are dealing with that. All right. So we can now talk about some key principles. You see, when I give you some content in the topic, I make sure that I give you the, the kind of tools that when you go out and you are checkmating what is happening in the real world on the practical sense with some of the content of this note, we can get principles, processes, and these are the things we are dealing with. So you can apply them whenever you see, oh, this is what they are applying here. Okay, this is sequencing. Okay, this is how we can do it. And this is what he made mention when he talked about learning outcomes. All right, when he gave us Bloom's taxonomy and different examples of verbs. By the way, take hold of that particular pie, which I showed to you, where you have verbs all in there. When you are doing your TP next year, you will need those verbs when you are writing your learning outcomes. There is no doubt about it. Take note. All right. So there are some key principles of sequencing topics in curriculum, in computer science curriculum. The first one is that conceptual dependency. These topics must be conceptually dependent. In fact, it's just that in most of the courses, programs in education, we don't have prerequisite courses. But I know in Faculty of Science, they have some courses that are prerequisite to another. Okay? Where we have to pass the prerequisite course before you move on to the next course. All right? So this concept there, this is very important to ensure conceptual dependency. And it also helps you to ensure smooth progression. If you deal with conceptual dependency very well, you'll be able to have a smooth progression, okay, along these contents. And it will avoid overwhelming, because you are now breaking a course into 2 or 3 and then bringing them in, introducing them to students in accordance with the complexity. What you introduce in first term should be at least the simpler one. So when you get to second term, it should be a little bit advanced. When you get to third term, it should be a little bit advanced. By the way, maybe part of our project in this particular lesson, in this particular course, will be on look at the curriculum itself, the computer science curriculum, and they call it computer and IT. As soon as I get the document, I can bring it to class. So we now see the connections between this. How you will see they repeat same topics about 4 or 5 times. The topics that are covered in SS1, they are repeated in SS2. And they are also repeated in SS3, but in different levels of complexity. So you will see that when we are looking into some of these things, the document, we can study them together in one of our classes, okay? It will allow you to avoid overwhelming, all right? Then you can ensure, another principle is to ensure gradual complexity. You start with foundational concepts and skills, they introduce advanced topics, you reinforce understanding. That is, you repeat same content, same concepts often, so that your students will get it into them. Another key principle in the sequencing is what we call spiral approach. We can see the diagram, it's more of spiral, but what you see there are actually staircases, okay? They're actually staircases, okay? All right, so the spiral approach, it means that you are just moving back and forth. You are injecting concept into each other. You revisit concept periodically so that students can see the connection between them, and then it is spiral. As soon as you see that, okay, they have got this a little bit, you move a little bit forward. You come back again. You move a little bit forward. You come back again, and that's how you deal with it, okay? Then this will help you to actually promote what we call retention. Okay, which is the ability to keep your knowledge in the long-term memory, according to those who they call cognitive psychologists. So for cognitive psychologists, they believe that we have short-term memory and we have long-term memory. Okay, just as we have it in computer, because computer is actually built on the principle of cognitivism. All right, so they believe that there is long-term memory where you keep so many things that you hardly forget. And you have short-term memory. Okay, you have seen his face. It's not important. Whatever thing it says, it just enter through one ears and go through another ears. Okay, that is short-term. But we encourage you, as students of computer science, to keep your knowledge in long-term memory. And how can you do that? We ensure that through designing your curriculum in a spiral approach. So somebody that is talking about cognitive processing or ability and curriculum, you can see, if you design your curriculum in such a way that there is spiral approach in there, if the student didn't get it in SS1, he must get it in SS2. If he didn't get it in SS2, he must get it in SS3, because that is what? Spiral. If he didn't get it in first term, he must get it in second term, or else he gets it in third term, repetition. So that's why for some parents that used to skip classes for their students, for their children, is very bad. For some parents now, as soon as the students reach SS2, they ask them to go and write WAEC. You know, so that they will skip SS3. What about the content in SS3? Where are you rushing the students to? They get to the university and then they mess up. The same thing. Those in primary school, My child is brilliant too. I don't want him to pass through primary 4. So from primary 3, if you just do common entrance, or from primary 4, if you just go for common entrance, you won't pass through primary 5. So these are some of the challenges we face. If you understand this spiral approach very well, you know that, oh, these parents, they are doing something wrong to their children. Okay, the knowledge will not sit in their long-term memory if this spiral approach is not, you don't allow the children to pass through this spiral approach. All right, the next thing we'll talk about is about the scaffolding strategies. What about the strategies? Again, it's part of the principle that we are dealing with. So where you scaffold, and when you scaffold, it means you are providing what we call temporary support. And look at the diagram we have in there. So this is kind of a cage or scaffold that they make. Perhaps they want to paint the building. By the time they finish painting the building, you will see that they will collapse this scaffold. The scaffold has done its work because it was just there to provide a kind of temporary support. Or they want to do plastering of the wall, high building. The hand of the mason cannot reach the top of the roof. No, it needs scaffold. So scaffold also, it applies to what? It applies to curriculum. You need to provide temporary support to your students and even to teachers. So when they face some challenges, then you provide temporary support to them and then you move on. This will bridge the knowledge gap. What the student can do and what the student can do and what the student is able to do. The student can do something, fine, that is what he can do. Give him a problem, he can solve. But what he's able to do, but he cannot do on his own, he needs the support of teacher. Okay, with that support, with that temporary support, the student can do what he's able to do. But without that, the student will feel, oh, I cannot do this, this one is too hard for me. But if the teacher supports the student and then come in and encourage the student, yes, you can do it. This is how you do it. This is the starting point. And then you see that the student will pick up. So scaffold actually help to bridge the knowledge gap, and it promotes independence. But by the time you provide the temporary support, you now withdraw your support. You now see the student doing the thing on its own. So this is very important in providing in dealing with curriculum development. And we have some different types of scaffolding techniques that we can use. We have the modeling and demonstration. You can serve as a model. This is how you do. You can see a lady there demonstrating for that teacher. Okay, showing how to solve problems, some strategies. Oh, this is how to write the code, you know, and then you can now do your own. Then you try to do it on your own. They can make what we call guided practice, where you guide the student. That's what they do in practical labs. Unfortunately, most of your practicals are not taking place. Okay, so guided practice, where you will be practicing on your own, and then you run into errors. Say, sir, I have a question, and the sir will come and then say, this is the error. Look at it. Instead of you to put +1 here, you put -3. And change it, and then you find that the code will run, and then you'll be very happy. Yes, I've done it. So guided practice is another way to scaffold your student. You can make some kind of prompts and cues. Prompts. You ask the question, you see that the students are feeling sluggish to answer the question. Then you can say the question another way. Or you can even start answering the question. Then you see them picking up. Just like what happened some few minutes ago. I asked you a question. Some of you, or most of you, are like, oh, I don't know what to say. Let me just be quiet. Then I repeat the question using different words. Then I encourage you. I try to call 1 or 2 persons. Then before you know what is going on, people are bringing in their suggestions. And then, in fact, I even got tired of reading your text. So this is what we are saying. So as teachers, you should know how to use these strategies and then be able to apply them appropriately. Then you will be fine. So prompt and cues, they are very important. Take notes. Maybe by the time I was doing that, you don't understand, but now you can see the connection. So when you also get to your class, you try to incorporate some of these things. Okay. Another way through which you can incorporate scaffolding is pre-assessment and differentiation. You can assess student prior knowledge and skills and tailor your instruction appropriately. You can break your content into chunks, into small units. Just like we have lesson 1, lesson 2, lesson 3 in our course. And you can see we treat lesson 1 for 2 weeks before we introduce lesson 2. That will allow you 2 weeks, we allow you to digest the content in lesson 1. And that's why in my course, I don't do crash lesson. I don't do that. I hate it. Where the whole of the semester course will be taught in 4 weeks, that is nonsense. Because it will not give you the time to assimilate the previous knowledge before coming to the new one. You see it now. So we have some people that used to do that. At the beginning of the semester, they will not come. And when it is 4 weeks or 5 weeks to the end of the semester, you see them coming around and be rushing the student. This will affect the knowledge that you want your student to gain. The whole semester is spread across 15 weeks. There is a reason for that. So that at every instances, students will have chance to revise the previous knowledge before they come to the new class. So take note, when you also become a teacher, don't be a bad teacher. I used to do that. Bad teachers are the ones that used to collapse the curriculum and then overload the students within 3 or 4 weeks. That is not good. So gradual release of responsibility. So you can move from teacher-led instruction to independent application. This is very important. And I think we are also practicing that in our projects. So we've treated the topic on rubrics and assessment. Now it's your time to do it. Now do it. Let's see. So you are now free to explore the world on your own and then come back with report. Okay? So evaluating and refining curriculum. Remember, this is the last stage when we talk about the aligning the curriculum standard with learning outcomes. We evaluate and refine the curriculum. But this is the second to the last. Okay? So here you can talk about the formative assessment, you can adjust the instruction, and then you can talk about collaborative reflection. Okay? The last part, which is addressing inclusivity and diversity. Your curriculum should be all-encompassing. Should be able to take care of people of different backgrounds, of different tribes, of different languages, of different, culture, of different dispositions. Your curriculum should not be skewed to one place. That's why the use of one local language to teach is going to fail. Because local language is very complex. Nigeria has more than 400 languages. I hope you know that. We have more than 250 languages with more than 400 tribes in Nigeria. So in fact, in a state like this, we can have 10, 15, or 20. In fact, I was told that in one state in East, where they have 21 local governments, and they have 20 different languages. You see, one person from one local government cannot communicate with another person from that local government unless they use pidgin English. One state like that in the East. Maybe Max will tell us more about the state. 21 local government and 20 different languages. Each local government has its own language. Each local government, and one language does not communicate with another one unless they bring a common point. And that common point they use is pidgin English in the East here in Nigeria. So be careful. So you need to understand diverse learners, and then you tailor your instruction to make sure it fits into the diverse learning of your students. One of the approaches you can use is what we call differentiating instruction, where you can modify your instructional materials a little bit. Don't just make it all text. And that's what I try to preach and what I do. I don't just come to class, I teach you, just dictate notes. No. We can incorporate that, but we can do more. We can bring in graphics, videos, technology. If you are the type that don't like attending classes, but you are the type that can watch videos, you can watch series of movies. Why don't you watch your lesson like you watch movies? So we create that opportunity for you. If you are the type that like to talk, you like to talk a lot, and we create an avenue for you to discuss with your colleagues and debate on the content. So this is what we say. With that, we'll be able to accommodate a lot of persons. Okay, you are the one that cannot do well in, you don't like recalling and writing in text. Okay, we are giving you opportunity to present, or we are giving you opportunity to conduct a project and then come up with solution, which can be graded. These are the kind of things that you look into when you talk about differentiating instruction. Modify instructional materials appropriately, adjust instructional, and then assess your student learning accordingly. Implement mix of both formative and summative. Implement different types of assessment tasks. Okay, and then you move on from there. Then we talk about identifying and assessing specific needs of your students. So you need to look at students with learning disability. You need to accommodate them in your class. Give them extra time. Give them visual aids. You see, show them pictures, show them videos. Let them have podcasts of your lesson. They can listen to it. If you cannot watch videos, you can listen to lessons. And then you provide that opportunity. You come to your class, you record the session, and you post it online so that your students can do it. For those of you that can join here, kudos to you. We have some of you that are willing to join, but cannot. Maybe they don't have iron phone, they don't have data, they don't have whatever. There are a lot of problems. But now, after the lesson, you get the video, you can watch it on your own. This kind of opportunity we are saying. English language barrier, or yeah, this is another thing. You need to scaffold instruction. Now, we have some people, some set of people that are not so sound in English communication. They need help, either by somebody to translate the lesson into their local language so that they can understand better.
One of my friends,
and then you provide this kind of support to them. Let's talk about the gifted students. Max, do your job. So the gifted students, we have they are very fast in learning. They can work on their own independently. You give them opportunity to make your lesson note available to them so they can read on their own. They don't have to come to class. My class is not compulsory, no problem. But they can read my notes. If you are gifted. You can read and digest everything on your own. Yes, we are going to meet in the exam. Yes. So this is the first aspect of the lesson, which is about aligning the curriculum with the standard. The second aspect is about the essential components of a computer science curriculum. Just only one slide. And we move to the last aspect, which is also one slide. I'm not going to take time on this because this is what you will do for 4 years, the component of computer science curriculum. And if ABU curriculum does not include these things, you need to collect your money back. Number one, the core concept and skills. We need algorithms. Your curriculum must include algorithms. I know you have a course on algorithms. Programming languages. I know you have about 2 or 3 courses on programming languages. We have data structures. That must be in your curriculum. We have computer systems, cybersecurity. AI must be in your curriculum, no doubt. If there is no AI in ABU curriculum, go and collect your money back. Okay? Then we have hands-on projects and activities. There must be coding projects. You must be able to have collaborative tasks. Things on robotics, this is the future. Then data analysis should be included. And this must be practicals, not theory taught in class. Assessment and evaluation should be both formative and summative. Rubrics and portfolio. I think you have some of this in education. All right? Then resources and tools. There must be what? Textbooks, online resources available to you. Development environment and virtual lab. There must be labs where you can work. But if there is no physical lab, they can produce what we call virtual laboratories, where some of these coding experiments, you can do them virtually. Okay? Take notes. This particular slide summarizes the content, essential component of the curriculum. So if you have the opportunity tomorrow to modify ABU curriculum or to modify secondary school curriculum, remember to reflect on all these things. I'm not sure if we have AI now in the secondary school curriculum, and it is overdue to have it. Okay? I'm not sure if you have something on robotics in secondary school curriculum. It is overdue to have it. So take note. All right. So the last aspect of our lesson today is on the strategies for implementing the curriculum. After this, I will stop, we interact a little bit, and then we call it a day. So what about the strategies for implementing curriculum? We have learned about how to develop the curriculum. We have learned about the curriculum components. And the last aspect is what are the strategies we can use to implement our curriculum? Number one, we need to conduct. There are only 3 strategies I'm bringing in here. Take note. You see, I'm giving you this point so that if there is any issue on it tomorrow, you can always remember them like this. Okay? When I give you a question on these strategies, for instance, I want you to give me these 3 aspects of it and explain in your own words. Number one is what? You need to conduct a curriculum review. For every curriculum implementation, it must start with what? Review of existing curriculum. Analyze those existing curriculum very well so that you identify weaknesses where you can improve upon, and you can identify strengths where you can reinforce. Take note, conduct a curriculum review, 4th stage. The 2nd stage is addressing content and pedagogical expectations. How do you want us to teach these things? How can we modify the instructional materials and strategies for teaching them? And lastly, you need to support diverse learners. You need to support people with special needs. You need to make sure your curriculum, it carries everybody along. So this is, I think, is a convenient place for us to stop. I will stop sharing my screen. Then we'll have some time to talk. Then we can proceed from there. All right. Okay. So far, any question, comments, recommendation? Stop sharing your screen. All right. So now you can now unmute yourself and speak your mind. Let me also go to the chat. It's like some things are in there. Okay. Oh yeah, that's true. Sorry, Max. I didn't make you a host before we start. Okay, good. All right. So yeah, comments, recommendations. I can stop this one now.